Hello colleagues, welcome to the new interview at Rosmould channel. In our previous interviews, we discussed different cases with such companies as Audi, Continental, Ricoh, VDMA, Mind, and many others. Please follow the links in the description of this video to watch them. And also the registration to visit Rosmould exhibition is available now. Today we will talk with Stefan de Groot, Master Science, Technology Manager and Project Leader at the PROTIQ company. We will discuss the process of additive manufacturing in service company and we will even discuss serial manufacturing. Is it possible right now or not? Hello, Stefan.
Hi, nice to meet you and thank you for having me.
Thank you for coming. My first question, so please tell about the PROTIQ and what kind of services you can offer.
Yes, yeah, so thank you for this question. I would like to give a short overview about PROTIQ and who is PROTIQ and what are we doing. And by this, I would like, I have to differentiate between two business models which we are working with. So at the one side, PROTIQ is a service provider for 3D printing, the PROTIQ production. And on the other side, we are also a platform provider for additive manufacturing, so that the PROTIQ production is also a service provider on the PROTIQ platform. And by this we are 100% subsidiary of Phoenix Contact, which is our mother company, an innovative market leader in the branch of electronics and automation systems, for example. Yeah. As I already mentioned, we are on the one side the service provider for 3D printing with our own production for selective laser sintering, for the selective laser melting, so the powder bed based processes. And we are a service provider for technical plastics, for metals and everything. And on the other hand, we are also the platform provider for additive manufacturing, so that we have a kind of a marketplace for additive manufacturing, so that also other service providers are able to offer their services and their materials on our platform, so that the big benefit for our customers is that they have everything in one place. So we have a huge number of materials on the platform from different service providers, and our customers able to use it with fully flexible 100% flexibility, 24 hours a day, 7 days a week, and can get live prices on our platform after uploading his 3D file.
Okay, could you please show the arrangement of additive manufacturing in the company?
Yes. So here you can see some impressions of the PROTIQ production of the analog business model, so that you can see on the upper left side the production for laser sintering, as well as the lower left side where we are working with standard machines as well as one self-built machine. And for the standard production, for the daily production of standard materials for additive manufacturing, like polyamide 12, alumide, polyamide 12, which is flame resistant, and comparable materials, we are working with standard machines from EOS, for example, or Ricoh, Protways, Fasoon, and 3D Systems. And furthermore, we have also the production for laser melting, which you can see in the middle of the slide. And in this context, we are also using standard machines for the daily business for the standard materials, like a stainless steel, a tool steel, aluminum, and the common materials for additive manufacturing. And furthermore, we also have developed here another self-built machine on which we are also able to process innovative materials for additive manufacturing, like for example high conductive coppers or
I
zinc.
think we will talk about the materials later.
Okay.
But to understand the process, first of all, the person should upload the CID file. And
Exactly.
after that, could you please show your next steps?
So yeah, we will start with the start page. The customer is able, or our customers are able to directly upload their 3D files on our start page. That means he can simply choose the demo component for presentation purposes now, and then it is uploaded on the platform, and our algorithm are checking the part in terms of producibility, wall thicknesses, and geometrical dimensions, for example. And after this, the customer gets a direct visual feedback of the uploaded part with the file information, for example. And then the customer is also able to directly jumps into the materials or material overview and can simply choose the desired material out of all the materials which we are offering on our platform. So for example, the top materials, as well as plastics, metals, ceramics, or glasses. And when the customer is would like to obtain this or to order this part made of polyamide 12, he also gets the live pricing. So immediately after uploading the part, the customer gets the live price information, so that he's fully flexible 24 hours a day, 7 days a week in obtaining quotes. And so this whole process of obtaining quotes can be reduced significantly. And after this, when he has decided for the polyamide 12, for example, he can have a look which service providers on our platform are offering this material. And for each service provider, the customer also gets the live price information for this product, for this part. And then you can simply select the customer or the service provider he would like to work with, select the material, and then we also have a scale effect on the platform. So if the quantity gets higher, the price per piece gets lower, for example.
And if the customer choose another service provider, you will not print their parts. Is it correct?
Yes, exactly. So the platform is really a marketplace, and the customers are able to to choose the desired service provider, which is also from which you can also see the logo and everything. And when he chooses another service provider, for example the FKM laser sintering, the order would be placed directly at this service provider.
Okay.
So
so other steps are quite understandable. So then person choose the quantity and then pay for it. And after that, he will be waiting for his details.
exactly. So comparable to any other online ordering process, he gives his contact information, chooses the shipping method, the payment method, says order now, and after this, a few days later, he gets his parts and his.
And if we are talking about the serial production, is it any difference, or the person or the company can also change quantity to, for example, 1 million?
Yeah, so it's possible to also change the quantity to higher quantities, but especially when we talk about serial production with big players, for example, we have to talk about many details and information and tolerances, for example, and any other things which are very important for the customer, for example. And so there yeah, a personal contact is yeah, very beneficially. And so the ordering would also be on the platform, on the marketplace. But when we talk about serial production, of course, we are also able to do manual calculation on basis of the optimum batch sizes. And so, yeah, the customer is able to gain an advantage in terms of reduced prices for serial production.
But PROTIQ is not only service company, you also develop some innovative materials. So
Exactly.
please describe these materials and real cases.
Material development and innovative materials for additive manufacturing is a very important fact for us. Because yeah, to be honest, the standard materials for additive manufacturing, every service provider is able to offer standard materials for additive manufacturing. This is a quite good business, and there's a big demand for standard materials like the polyamide 12, a tool steel, a stainless steel. But at some point, we also have seen that there's a big demand for innovative serial materials for additive manufacturing. So serial materials which have been, yeah, standard materials for the conventional manufacturing for years, which are not, or which have not been yeah, obtainable in additive manufacturing. And because of this, we have an own research and development, and because of this, we developed own machines to be able to offer these innovative materials like the polyamide 6, for example, or the high conductive copper, as well as our zinc material, Zamak 5 material, and the brass material. And now I would like to give a short overview about the copper materials on which we are able to offer at PROTIQ. So this makes our customers yeah, give the customer the big advantage for brand new applications for additive manufacturing. So for example, for heat exchangers, as well as DC applications and charging plugs with internal cooling systems. And with this innovative materials, we saw that we also needed to have this personal contact again with our customers, with the big players, to do workshops and find the right application with our customers. And one specific application which offers really huge potential and many benefits for additive manufacturing of high conductive coppers, for example, is the area of induction coils, inductive heating, and inductive soldering, for example. For the traditional manufacturing, it is characterized by a fully manual process, so that, for example, a copper tube is filled with sand and has to be bended and soldered manually. And based on this, by using templates and considering bending radii, we have many different single components which are combined, and therefore we have many areas which are, yeah, which includes many possible breaking points after a short application time. And the big advantage for additive manufactured copper and induction coils is that we can merge all the different single components to one component and produce it in one building job with 100% reproducibility, for example. And by this, we can also optimize the part geometry of the induction coils, for example. And this also gives the big benefit of simulation-based optimization. So we are also able to do an optimization of the whole heating and inductive heating process by using the traditional design as a basis, do a magnetic field simulation as well as a simulation of the heating process. And after this, we can do a design optimization and can directly print it on our machines. So that we are able, when the design optimization is done, we are able to print the part within 1 or 2 days. And this is really, yeah, much more faster than the traditional manufacturing. And yeah, this week we were also able to finish our new demonstration for demonstrator for induction coils, which includes, yeah, mostly every advantage of additive manufacturing in comparison to traditional manufacturing for this coil application. And yeah, this you can see here. And the big advantages of additive manufacturing presented here are generally greater design freedom and functional integration. So that, for example, we have smooth transitions of windings to improve the water and the current flow. We can avoid sharp edges and solder seams significantly, and increases the coil life and reduce the failures. We have yeah, lower two coils contain we have contained an additional cooling channel to integrate a quenching function during the curing process in the heating application. And then we have a quick coupling for water connection that can be printed directly in one piece, just like, yeah, any other components. We have the cross sections of windings can be freely selected and varied over the coil height, so that we are able to make a bigger wall thickness in special areas of the inductor. And it's also possible to add a labeling with serial number or article designation directly on the coil. We can add mounting bolts that are provided for mounting the coils in the application process, and yeah, many more. As I told you before, the reproducibility is one of the biggest factors and one of the important factors for our customers, because with the additive manufacturing, we are able to produce the same coil in batch size 10 or in batch size 100. It's a 100% reproducibility, and we are really much more faster than for the traditional manufacturing of coils. So yeah, this should be a short example for the induction coils. And furthermore, another interesting area is the ZEMAC 5, the zinc material, which is also processable in additive manufacturing for as a substitute for zinc die casting. And by this we can also, or we are also able to offer serial production for very high quantities, not that high quantities which we know from the zinc die casting in traditional manufacturing, but for quantities of 100, 200 or 300, for example. We are able to also address the big advantages of additive manufacturing, that we do not need any expensive tools to start the production, and be able to do an economical production beginning at batch size 1, and can therefore reduce time and costs significantly.
Okay, thank you so much. So please subscribe our channel, and see you at Rosmould.